So in this video, we're going to talk about a device called an electroscope. And you can see an example electroscope right here. You can also see a slightly different type of electroscope if you're looking at the Knight textbook, the pink book on page 637. So you might want to refer to that page for an example like the one that we're going to do right now. So there's several things that I want you to pay attention to in this video we're going to do. I hope that by the end you'll know how an electroscope works. You should know 3 different ways of charging a material, and we're going to demonstrate all 3 of those ways during this video. You should also understand the concept of polarization of an object and what that means. Also the concept of electronegativity or electropositivity. And then finally the concept of grounding. We're going to talk about all those things in this video. So let's start with the parts of the electroscope. So you can see the electroscope has a metal ball on top, and over here on the board I just have a schematic diagram, so this would be the metal ball. The important thing about that ball is it is connected by metal, by a conducting path, to this kind of backwards S-shaped metal piece that's underneath it. And it is also connected by a conducting path to this straight piece that I've drawn in red on the board. It's a silver piece here, and it's a straw, a very lightweight straw made of metal. And that straw sits on a needle here in the middle. And that needle allows the straw to turn, so it's not fixed in place. So I'll just demonstrate there. It's very, very nicely balanced so that it can pivot. All right? So that's the main parts of this electroscope. There's also this black ring around the outside, which is made of metal, which is not electrically connected to the S piece or the ball or the straw. It's separated by an insulating piece here. So this black plastic is actually insulated. And there's no connection here at the bottom. We'll talk another day about the purpose of the black ring around the outside. We're not going to be discussing that today. All right, so that's the parts of an electroscope. So let's talk about 3 methods of charging. So you should have learned about most of these methods in the electrostatics lab that you've done. So I'm going to start with a balloon, and the balloon I'm going to test with the electroscope to see if the balloon has a charge before I do anything to it. So the purpose of an electroscope is to allow us to see, if I bring an object near it, it can tell me if this object is charged, as we'll see. So I'm just going to hold my balloon near that ball. I'm not going to touch it, and see if something happens. And the straw is not doing anything, so that tells me that this balloon right now is electrically neutral. All right, now I'm going to give this balloon a charge. I'm going to use some rabbit fur, and I'm going to friction the balloon. Before I do that, I want you to understand something about electropositivity and electronegativity. So different materials hold on to their electrons with different strengths. So that's what we mean by electropositivity. So it's a relative term. I can compare 2 materials and see which one is more electropositive. The one that is most electropositive out of these 2, actually, when I friction them, the one that's most electropositive will lose its electrons very easily. The one that is more electronegative holds on to electrons and will gain electrons in that process. All right, so the reason we're using rabbit fur is when compared to almost any other material, rabbit fur is very, very electropositive. And that simply means that it easily loses electrons to any other material that you would friction with the rabbit fur. So again, the balloon started neutral, After I rub it with some fur, the balloon has acquired some electrons, and electrons have a negative charge. So I'm going to just bring the balloon close to the electroscope. Something should happen this time. And I'm going to bring the balloon away. So I did not touch the electroscope. I just brought it near that ball. And hopefully you noticed that the straw deflected. The top part went to your left, and the bottom part went to the right. So I'm not going to explain what's going on. I want you to think about what caused that straw to deflect. If you look at the example in the textbook, you might get some clues. And in class, when we go over this, I'm going to have you try to draw pictures of what the charges in that electroscope were doing when I had the balloon nearby. Notice that nothing touched the electroscope, so there was no transfer of charge to or from that electroscope, so it's still electrically neutral. It was electrically neutral the entire time, and when I took the balloon away, the straw went back. Okay? I'll give you one hint about what happened, and you should read about this in the textbook as well. It has to do with something called polarization. So, and we'll talk about polarization in class. All right? So we've just gone over one method of charging an object, which is charging by friction, right? And we demonstrated that the balloon was charged by bringing it near the electroscope. All right, now I'm going to demonstrate a second method of charging an object, right? I recharged the balloon. It has a negative charge. This time I'm going to bring it close to the electroscope, and I'm actually going to touch the ball on the electroscope, and I want you to see what happens. Make a prediction first. What do you think will happen in terms of charge transfer when I touch a negatively charged balloon to that neutral metal ball? Okay. I touched it, nothing happened, so I'm going to try one more time. It's a little bit humid in here. I'm trying to get the air dry with dehumidifiers. Let's see if I can make something happen. So there was no charge transfer. If there had been, you would see the straw doing something different. Okay. It wasn't a large charge transfer, but the straw is no longer vertical, and that means that something has happened to that electroscope. So I'm not going to draw pictures right now, but in class I'm going to ask you to think about what must have happened when I touched the balloon to the electroscope, and what the charges inside the electroscope must look like right now. Okay? Clearly, it's not neutral, right? If it were, the straw would be vertical. Okay, so we just did an example of giving something a charge. In this case, we gave the electroscope a charge by contact or conduction. When a charged object touches a neutral object, there can be a transfer of charge. That's called conduction, or charging by contact or conduction. So that's method 2 of charging. All right, I'm now going to do something a little different. I'm going to touch with my hand, I'm going to touch that metal ball. Now, I'm a neutral object. And the human body is a pretty good electrical conductor. So if that has a charge, and I'm neutral, and I'm a conducting path, the charges on the electroscope, whatever charge that is, whether it's positive or negative, you can think about. But the charges that are there, because they are like charges, are repelling each other. When I give them a conducting path, they will spread out, all right? And so a name for what I'm about to do is called grounding, and you might have heard of that. So I'm a large conductor, and when a large conductor makes a conducting path to some other conducting object that's relatively small, that's called grounding, right? And so, for example, in your house, the wiring in your house, your appliances are all grounded. There's actually a conducting wire from your appliance into the ground, and the earth is a very large conductor. So that's why we call this process of touching a large conductor to a small one grounding, right? And what that's going to do in this case is allow the charge from the electroscope to just disperse to me. In your home, it has a safety purpose, which we'll talk about another day. All right, so I'm just going to lightly touch this. And nothing happened. I'm going to try one more time. Okay. All right, I had to touch it a few times. I'm not sure exactly why, because for grounding, if there's a true conducting path from that conductor to me, as soon as I establish that conducting path, the charge should be able to very quickly disperse to me, right? That didn't happen. I had to touch it a couple times. It might be because of a little bit of friction in the pivot there from the straw. I'm not quite sure. But it is back to neutral. Okay, so we've learned what grounding is a little bit. All right, now we're going to do one final demonstration with this electroscope. All right, so this has several steps, so watch closely and think about each step. The first thing I'm going to do is recharge this rabbit hook to the balloon. All right, so this balloon has a negative charge. I'm going to bring it close to the electroscope, but I'm not going to touch the balloon to the electroscope. Instead, I'm going to take my hand and touch it on the opposite side where the balloon is. I'm going to touch the ball of the electroscope on the opposite side where the balloon is. So you can think about why I'm doing that and what's going to happen to the charge of the electroscope when I do that. If you want to see an example in the book that's very similar to what I'm about to do, you can look in the Walker textbook, the blue one, on page 648 and 649. It goes through this. All right, so here we do it. I'm bringing a negatively charged object close, but not touching. I'm going to take my hand and touch on the opposite side. And then I'm going to take this negatively charged balloon away. So notice the electroscope now has a charge, actually a pretty strong one. But I never touched it with an object that was charged. All right? So this is a third way of giving an object a charge that does not involve contact with a charged object. And it didn't involve friction, right? So this is called charging by induction, and you should read about that in the Walker book, page 648. And when we have class, we're going to draw diagrams for this as well as the other two examples of charging that we just went over.